Hi students, our topic is about how do metals and nonmetals react. Before starting the discussion, you should note down some important points about metals and nonmetals. This is a periodic table which consists of both metals and nonmetals. In the left hand side you can see the metals and in the right hand side you can see the nonmetals. The atomic number, it is written here with all metals and nonmetals. According to the atomic number, we are writing the electronic configuration of both metals and nonmetals. It is impossible to by heart all the atomic number, but try to by heart atomic number of some important metals and nonmetals according to your syllabus. So here it is written some important metals and nonmetals atomic number and their electronic configuration. Note the point, metals have 1 to 3 electrons in the outermost shell. Here you can see 1, 2 or 3 electrons in the outermost shell of metals. Nonmetals have 4 to 7 electrons in the outermost shell. Here you can see 5, 6 or 7 electrons in the outermost shell. Nonmetals consist of 4 electrons in the outermost shell. That is a different category and that we will discuss in chapter number 4. Here we are considering the nonmetals which consist of 5, 6 or 7 electrons in the outermost shell. Both metals and nonmetals have a tendency to complete the octet level. That means they are trying to fill 8 electrons in the outermost shell. Here you can see for metals very less number of electrons in the outermost shell. So it is easier for the metals to lose electrons to complete the octet. That means if 1 electron it is losing from sodium to 8, it completed the octet. If 2 electrons this magnesium it is losing to 8, it will be completed the octet. But consider the nonmetals. Here more number of electrons in the outermost shell. So it has a tendency to gain electrons to complete the octet. That means here 5 electrons. Okay. So if 3 electrons nitrogen it is accepting here, it will become 2, 8. Octet will be completed. And here 7 electrons in the chlorine. So if it is accepting a single electron, the octet will be completed. So in this way metals and nonmetals they are transferring the electrons. I will show you one example here. Consider a metal, sodium. Its atomic number it is 11. So the electronic configuration will be 281. Consider a nonmetal, chlorine. Its atomic number it is 17. And the electronic configuration it is 287. So let us check how the sodium and chlorine reacting together to form sodium chloride compound. Here you can see 1 electron in the outermost shell. So if sodium it loses this electron, okay, the octet will be completed for sodium. It will be 28 then. For chlorine, here 7 electrons in the outermost shell. So 1 electron it gains here. The octet will be completed for chlorine also. So this is happening between sodium and chlorine. So this transfer of electrons between the metal and non-metal we will represent with the help of electron dot structure. Electron dot structure means first we will write the metal sodium and how many electrons in the outermost shell? 1 electron, right? So that electron we will represent here. Plus chlorine, the non-metal chlorine, how many electrons in the outermost shell? That is 7. So we will represent the electrons of number of electrons in the outermost shell for non-metals. It is with a cross mark like this. 7 electrons for chlorine. And this electrons it get transferred to here. That means sodium it is losing its electron and it is giving the electron to chlorine. So the chlorine octet level it is completed now. In the product side we will represent the sodium and chlorine in 2 boxes. This is sodium This is chlorine. Sodium, it loses one electron. That means it gains a positive charge. The charge of electron, it is negative. So if it loses electron means it gains a positive charge. So sodium plus here. Chlorine, it receives electrons from sodium. That means it accepts electron and it gains negative charge. So negative charge for chlorine. And for non-metals, finally we will represent the electrons in the outermost shell, that is 8. Okay, so this is the way we will represent how the transfer of electrons it is happening between metal and non-metal. Consider other example. Magnesium oxide compound. Okay, let us check how magnesium oxide it is forming when reacting magnesium and oxygen together. So the magnesium atomic number it is 12 and the electronic configuration it is 282. Oxygen, the atomic number it is 8. So the electronic configuration it is 26. So you can see here, if magnesium it is losing 2 electrons, okay, octet will be completed. Here oxygen it gains 2 electrons. The octet for oxygen also it will be completed. So we can represent this with the help of electron dot structure. First magnesium. How many electrons in the outermost shell? That is 2. Plus oxygen. How many electrons in the outermost shell? That is 6. So these 2 electrons it is transferring here and it forms magnesium oxide now. Magnesium and oxygen will be in 2 boxes in the right hand side. Magnesium it loses 2 electrons. So that means 2 plus. Oxygen it gains 2 electrons. That means 2 minus. And for oxygen the 8 electrons we will represent here. So in this way a metal and non-metal reacting to form compounds. So when a metal and non-metal react by the transfer of electron, a special bonding, okay, this kind of a bonding it is forming between metal and non-metal. Such bonding it is known as ionic bonding or electrovalent bonding. So the compounds formed because of this ionic bonding or electrovalent bonding, it is known as ionic compounds or electrovalent compounds. The compounds formed by transfer of electrons from a metal to non-metal are known as ionic compounds or electrovalent compounds. So I hope you understood how a metal and non-metal react. Thank you for watching the video. Please like and share and don't forget to subscribe the channel to get notification for new videos.